Long before humanity had words for the stars, the night was a mirror of mystery. The earliest eyes to look upward saw not infinity, but enclosure. The heavens were a ceiling, its stars tiny fires scattered across a dome of imagination. Myths were born there. The sky was the boundary of the known, and the light above was thought to watch the world below. Yet beyond those ancient flames, farther than any dream or god or tale could reach, something unseen was waiting, a universe unmeasured, patient, and endless. The first glimmer beyond darkness was not an explosion or a noise. It was silence given shape through light. Across incomprehensible distances, beams of energy began a journey that would last billions of years, threading through expanding space, passing through clouds of gas, drifting across voids vast enough to swallow entire galaxies. Each photon carried a memory, the record of a place that once burned, a point of origin no longer there, its stars perhaps long extinguished. That light travelled with purpose, though none existed to witness it, until one night, somewhere on a small planet circling an average star, a lens caught it. A telescope in the hands of a curious being became the doorway through which the universe revealed its true scale. Within the eyepiece was a dim blur, faint and ghostly, a smudge of light that resisted clarity. It shimmered at the edge of perception, whispering a story that had waited an eternity to be heard. The eye that looked upon it did not yet understand that this faint spiral was not a cloud inside our own cosmic island, but another island, entirely a collection of billions of stars adrift across unimaginable distance. That was the moment everything changed. The night sky was no longer a ceiling but an ocean. Each faint glow hinted at more worlds than imagination could hold. What had once seemed the entire cosmos became only a single shore on an infinite coast. The familiar constellations, so cherished and named by countless generations, suddenly appeared small, their stories dwarfed by the revelation that beyond their faint outlines existed countless other skies, each with their own suns, planets, and perhaps their own watchers looking back. To glimpse that faint light was to confront time itself. The glow reaching the lens had left its source before Earth was born, before oceans existed, before the molecules of life assembled. What was seen was not the present, but the deep past, preserved in motion. The observer was not looking outward, but backward. Light became the measure of memory, and distance became time stretched thin. Every observation was a conversation with history, each galaxy a letter written by the early universe and delivered across eternity. That realization carried a quiet kind of awe. The cosmos was no longer static, it was alive with movement, growth, and decay. Stars lived and died, galaxies collided, and light recorded it all. To understand that every spark in the sky was an echo from a different age, reshaped humanity's sense of being. The universe was not a backdrop, but a story unfolding, and humanity was both spectator and participant. The faintest shimmer held the weight of billions of years. Through that discovery, the cosmos gained a voice, not loud, but steady. Its language was written in wavelengths, in colors stretched by distance, in the silent expansion of space itself. What had seemed emptiness was revealed as fullness beyond comprehension. Darkness became a field of creation. Light was no longer simple brightness. It was proof that the universe remembered everything it ever made. Each night, more of these glimmers were found. They dotted the sky like distant embers, marking the presence of uncountable realms. The idea that there could be countless galaxies, each as vast as the Milky Way, felt impossible, yet undeniable. The universe had grown from a few thousand visible stars to an empire of billions of galaxies, each one a cathedral of light suspended in endless black. And through that growing understanding came humility. To realize that the Earth is not the center, not even a remarkable corner of the cosmic expanse, was to understand that existence itself is fragile, fleeting, and miraculous. Yet, within that smallness, there is beauty, for consciousness arose in one corner of this vastness, and it now looked outward, recognizing itself reflected in the starlight. Every photon striking the human eye was an ancient greeting, a spark of connection across impossible space. The first glimmer beyond darkness was more than discovery. It was awakening. It marked the instant the universe ceased to be distant and became intimate. Humanity had stepped beyond mythology into truth, a truth grander, colder, and yet more beautiful than any story told before. The cosmos had always been there, waiting for someone to look deeply enough to see it not as a pattern of stars, but as an infinite unfolding of creation. That first glimmer was not just the beginning of astronomy, it was the beginning of wonder itself. It began in quiet nights at Mount Wilson Observatory, high above the city lights, where the thin air and cold wind met a man driven by precision. Edwin Hubble stood beside a telescope that was, for its time, the most powerful instrument ever built for the purpose of looking backward through time. Each photograph he took was a long negotiation with the universe glass plates waiting in darkness, exposed for hours to the faint whispers of starlight. To him, those small dots and hazy spirals were not decoration, they were questions. For centuries, astronomers had debated the nature of the faint clouds in the sky, known as spiral nebulae. Some believed they were gas within the Milky Way. Others suggested they might be separate systems entirely, each one its own realm of stars. But the tools to decide were crude, and the distances unthinkable. The universe, as far as most knew, ended at the edge of our own galaxy. Beyond that, it was assumed, lay emptiness. Hubble refused to accept assumption as fact. Through his telescope, he saw the great spiral of Andromeda and decided to measure it carefully. Within that vast blur, he searched for something familiar, a specific kind of star known as a Cepheid variable. These stars rhythmically brightened and dimmed, and their pattern of pulsing revealed a secret. Their true luminosity could be calculated, and from that, their distance determined. Night after night, Hubble recorded the light of one such star flickering in Andromeda's haze. When the calculations were complete, the answer struck with the force of revelation. The distance was far too great to belong to the Milky Way. The faint spiral was not within our galaxy. It was far beyond a colossal system of its own, containing billions of suns. In that single moment, the known universe expanded from one galaxy to many, and everything humanity believed about its place in creation was shattered. Hubble's finding was not only a measurement, it was a transformation of perspective. The Milky Way, once the center of all things, became one among countless others drifting in a boundless sea. Each nebula that once seemed a small swirl of mist was suddenly recognized as another universe of stars. The cosmos had multiplied in scale beyond imagination. His photographs became more than data. They were evidence that the night sky was deeper than anyone had dared to believe. Each image captured was a revelation of vastness, a truth written in light that had traveled for millions of years to reach a single glass plate. The notion of emptiness between the stars dissolved. Space itself had become populated with colossal structures, each carrying its own history of birth and death. From that discovery came a new realization. The galaxies were not fixed in place. They appeared to be moving, and not randomly. The farther a galaxy was, the faster it seemed to recede. Hubble and others began to see a pattern in the redshift of spectral lines, the stretching of light toward longer wavelengths. This was not coincidence. It was expansion. The universe itself was growing, and space was carrying everything within it outward. That revelation upended ancient comfort. The cosmos was not a steady, eternal stage. It was dynamic, evolving, restless. Every distant galaxy was fleeing from every other, carried by the fabric of space, as if on an invisible tide. The night sky, serene to the naked eye, was in truth a vast motion picture unfolding over billions of years. Hubble's work showed that time and space were not static partners, but intertwined forces shaping each other. In his quiet, methodical way, Hubble had done something no myth, no philosophy, no empire had achieved. He had expanded the universe itself. His discovery bridged human understanding from the smallness of a single galaxy to the immensity of all existence. The word galaxy changed meaning. It no longer described a single home, but a family of countless homes, each spiraling, merging, and drifting through the expanding void. The implications reached far beyond astronomy. They changed the language of science, the imagination of poets, the philosophy of existence. To know that the universe was larger than any horizon could hold was to face a new kind of humility, one born not of fear, but of awe. Humanity was a flicker of awareness inside a cosmic web of billions of suns. The night was no longer a mirror of myths, but a map of truth, traced by light older than life itself. Every photograph Hubble took was a conversation with time. Every plate carried light that began its journey long before humanity could even dream of telescopes. When those images were developed, humanity saw not just the face of Andromeda, but a reflection of its own curiosity staring back through eternity. Hubble's revelation was the first moment the cosmos confessed its scale. From that confession came everything that followed: the concept of an expanding universe, the birth of cosmology as a science, and the understanding that reality is always larger than our ability to measure it. That night, when the distance to Andromeda was written into numbers, the universe became infinite in spirit. When humanity first saw beyond the Milky Way, it was like opening a door into an infinite cathedral. What lay beyond was not emptiness, but immensity, a universe filled with silent, drifting realms of stars, each one glowing faintly across inconceivable distances. The discovery that our galaxy was one among billions reshaped everything that could be known about existence. But knowing it intellectually was one thing, seeing it was another. The deeper telescopes peered into the heavens, the more the night revealed its endlessness. Through the great lenses and mirrored eyes of observatories, astronomers began to notice something astonishing. No matter where they pointed, the sky was never truly dark. Every direction shimmered with faint, distant galaxies, tiny specks of light that filled the photographic plates like grains of cosmic dust. What seemed like empty space to the naked eye was alive with hidden worlds, so far away that their light was only now arriving, carrying messages from the young universe. Each galaxy was an island universe, some shaped like spirals, arms unfolding in graceful rotation. Others were elliptical, diffuse, and ancient. Still others were irregular, distorted by collisions or gravitational tides. Some were vast, their diameters stretching hundreds of thousands of light-years, holding trillions of stars. Others were fragile dwarfs, faint whispers of starlight adrift in the cosmic sea. Together, they formed a grand architecture, a pattern that spanned beyond all scale, an expanse without edges. As maps of the universe began to take shape, astronomers realized that galaxies did not scatter randomly. They gathered in clusters, bound by gravity into massive congregations. Between these clusters lay enormous voids, immense stretches of near-nothingness, each spanning hundreds of millions of light-years. And through these structures, an invisible order began to emerge. Galaxies arranged like filaments of light, weaving the cosmos into a vast web. It was as though creation itself had drawn a network across the darkness, each intersection a cluster of worlds, each strand a bridge of gravity connecting distant realms. To look upon such structure was to feel both wonder and smallness. The scale of it defied comprehension. Numbers lost their meaning. Words faltered. The light captured by a telescope in a single night might contain the signatures of galaxies whose combined mass outweighed millions of Milky Ways. Yet all of that existed silently, indifferent to the gaze that sought to measure it. In the great expanse, time stretched and folded in strange ways. The light from distant galaxies did not show them as they were now, but as they once were, images from when the universe was young. In each photograph, scientists were not seeing space but history. Every galaxy was a memory, preserved in motion, still crossing the chasm between then and now. To explore the universe was to explore time itself. With each new telescope, the known boundary of the visible universe expanded. It became clear that there might be no end to it, no edge, no wall, no center. The universe had no middle because it was everywhere, expanding from every point. Space was not an object but a living fabric, stretching, curving, and growing. The galaxies were not flying through space. Space itself was carrying them apart. Astronomers came to realize that what they saw was only a fraction of what existed. Beyond the faintest galaxies visible to even the most sensitive instruments, there must lie others, countless more, their light too weak, too redshifted, too distant to ever be seen. The observable universe became not a limit of reality, but a limit of perception. What lay beyond could only be imagined, but its presence was inevitable. Within this endless expanse, beauty and terror intertwined. There was majesty in the thought of billions of galaxies, each filled with stars, each star perhaps with planets, each planet perhaps with oceans, storms, and life. But there was also loneliness, an understanding that the greater the scale, the more silence there was between each voice of light. The distance between galaxies was growing. The farther one looked, the faster they fled, carried by cosmic expansion into a future where contact would be impossible. Yet, in the midst of this vastness, a strange comfort appeared. For if the universe is infinite, then nothing is truly isolated. Every atom, every beam of light, every mind capable of wonder is part of the same unfolding story. The stars in one galaxy share the same cosmic origin as those in another. The hydrogen that fuels distant suns is the same that once swirled through the primordial clouds of creation. The expanse is endless, but its essence is shared. The deeper humanity looked, the more it became clear that existence itself is not about boundaries, but connection. Each galaxy, though drifting alone through space, is a verse in the same universal song. The night sky, once thought to end just beyond the stars, now stretches into eternity, a reminder that even the faintest light, no matter how far it travels, is still part of the same infinite whole. When a beam of light begins its journey, it carries no knowledge of where it will end. It leaves the heart of a star, passes through the turbulence of gas and dust, and enters the cold corridors of space where time stretches thin. That light, unwavering and patient, travels uncountable distances across billions of years before finding the small, waiting surface of a telescope's mirror. In that moment of capture, the present touches the ancient. The light that began long before Earth existed finally finds a witness. Every distant galaxy seen through a telescope is not seen as it is, but as it was. The farther away the light source, the further back in time we are looking. This is not poetry, but physics. The speed of light, though immense, is finite. What we see at this instant has taken billions of years to arrive. To look across the universe is to look across time. The sky is not a map of the present. It is an archive of everything that has ever happened. Astronomers learn to read this archive like historians of light. Each wavelength is a chapter. Each spectral line is a clue. When a photon reaches us from a galaxy billions of light years away, it tells a story that began when the universe was young. In its faint color, scientists can decode the temperature of ancient stars, the composition of primeval gases, and the rate at which entire galaxies were being born. The universe, through its light, narrates its autobiography in silence. This realization changed the purpose of astronomy. The telescope was no longer just a tool for exploring distance, it became a time machine. The deeper astronomers looked, the further back they reached until they found themselves staring into epochs when the first galaxies were forming, when stars were still gathering from primordial clouds. The night sky, serene and static to the human eye, revealed itself as a timeline stretching from creation to now, each point a living record of what once was. Light, fragile though it seems, is the most enduring traveler in the cosmos. It crosses the black void, surviving the expansion of space, the distortion of gravity, and the decay of energy. Even as the universe stretches, the photons do not vanish. They are merely changed, their wavelengths elongated, their energy softened, their color shifting toward red. By the time that ancient light arrives, it has become a whisper of its former self, yet it still speaks clearly of its origin. To study distant galaxies is to listen to these whispers. The oldest light reveals a cosmos in its youth, small, chaotic, crowded with newly forming stars. Galaxies that now drift serenely across the night once collided and merged in violent dances, their cores igniting with new suns. Through observation, astronomers can trace the universe's transformation from a dense fog of hydrogen to a grand mosaic of galaxies. Each photon that reaches us is a fragment of that transformation, preserved across billions of years. The look-back time of light is more than a scientific principle. It is a confrontation with scale. A galaxy 10 billion light-years away is not just far in space, it is 10 billion years distant in time. When we observe it, we are witnessing an era when Earth did not yet exist, when the sun's atoms were still scattered among the stars. The light now touching our instruments began its journey before life, before continents, before the idea of eyes to see. In that way, every observation of the distant universe is also a meditation on impermanence. The galaxies we see may no longer exist in the form their light portrays. Some may have merged, faded, or been torn apart by gravitational tides, yet their light continues to travel, carrying the memory of what they once were. The cosmos preserves itself through the persistence of light. To see is to remember. For astronomers, each image of a distant galaxy is both discovery and elegy. The deeper the view, the older the light, and the more profound the silence it carries. The Hubble Deep Field, a photograph of what once seemed empty sky, revealed thousands of galaxies, each one a fossil of time. What appeared to be nothing was in fact everything, the living history of the universe written across a single patch of darkness. The study of this ancient light gave rise to a new understanding. The cosmos is not static but evolving, and the evidence of its evolution arrives continuously, photon by photon. Every moment we look into the heavens, we are seeing the universe as it once was. The stars above are not companions of the now, but relics of what has already passed. The night sky is not a reflection of the present, it is the ghost of time itself. Yet within that ghostly radiance lies a kind of comfort. The light of ancient galaxies continues to travel, indifferent to decay, crossing the vacuum with unwavering purpose. Long after the stars themselves have faded, their light will keep moving, spreading their story through the dark. And when that light meets the eye, for a brief instant, two moments separated by billions of years become one. The universe, through the language of light, allows the past to live again. The universe does not speak in words, it speaks in light. Every galaxy, every star, every nebula sends out a signature, a harmony of color that reveals its essence. To the unaided eye, the night sky may seem silver and still, but through the instruments that separate light into its secret frequencies, the cosmos becomes a spectrum of meaning. In that spectrum lies the story of time, temperature, motion, and creation itself. Each color of light carries a different truth. The blue of a young star burns hot, fierce, and brief. The yellow of a mature sun glows steady and enduring. The red of an aging giant is softer, cooler, fading toward its quiet end. But when those colors are stretched across entire galaxies, something more profound appears, a portrait of cosmic evolution painted across the heavens. When astronomers began to collect the light of distant galaxies through prisms and spectrographs, they discovered that color was not merely beauty. It was information. Each shade corresponded to a precise wavelength, each wavelength a clue to the nature of what produced it. In those subtle variations of hue lay the fingerprints of elements: hydrogen, helium, carbon, oxygen, the very building blocks of stars and life. The colors of galaxies were not random. They were records of transformation written in light. The youngest galaxies shine with sharp blue light, their energy fueled by clusters of newborn stars burning millions of degrees hot. These galaxies are alive with creation, where dust and gas condense under gravity's pull, giving birth to new suns faster than they can die. Their color tells of birth of beginnings, of cosmic youth. Older galaxies, by contrast, glow in deeper reds and golds. Their star-forming gas has been spent, their youngest suns long extinguished. What remains are ancient stars burning slowly, radiating a softer, quieter light. Their red tones are not signs of weakness but of endurance, the slow embers of a universe that has aged gracefully. Through color, astronomers can trace not only the age of a galaxy, but its history when it was born, how quickly it formed stars, and how long it has been fading. Beyond intrinsic color, another transformation shapes the universe's light, the stretching of wavelengths caused by cosmic expansion. As light travels through the expanding fabric of space, its waves elongate. The further it travels, the more it shifts toward red. This redshift is not a trick of the eye, it is the imprint of motion itself. Distant galaxies glow redder, not because their stars are all old, but because space has grown vast between them and us. Their light is stretched, like a note lowered in pitch as the universe's breath expands. This subtle reddening carries profound implications. By measuring how much the color of a galaxy's light has shifted, astronomers can calculate its speed and distance, a direct link between color and motion. A galaxy's shade becomes a clock, marking the time its light has spent traveling and the expansion it has endured. Every tint and tone is a whisper of the cosmos stretching. But there are deeper mysteries hidden in color's quiet language. Some galaxies appear more luminous than they should, their light infused with energy from invisible sources. These are often powered by supermassive black holes at their centers, objects so dense that not even light can escape, yet so violent in their feeding that they ignite their surroundings into brilliance. Their light is blue-white and piercing, a deceptive purity masking unimaginable chaos. The color tells of hunger, of power, of destruction wrapped in radiance. In contrast, there are galaxies so faint that their colors barely register. They hover at the threshold of darkness, their light stretched thin by distance and time. To detect them requires patience measured in weeks of exposure, gathering every photon that drifts through the void. These pale, ghostly colors belong to the universe's early years, the time when the first galaxies began to shine through the cosmic fog. Their light is ancient, fragile, and sacred, a whisper from creation's dawn. When astronomers collect these colors and map them across the sky, the result is not chaos, but harmony. The universe glows like a grand mosaic galaxies of blue youth, red age, golden calm, and violet fire scattered across infinity. Each one contributes to a silent music, a chromatic rhythm that speaks of birth, growth, decay, and rebirth. To gaze upon such a palette is to understand that beauty and physics are one. The same processes that give rise to color in the sky, energy, motion, temperature, time, also give rise to life. The elements that burn in stars are the same that pulse within living cells. The reds and blues of galaxies are the fingerprints of chemistry itself, the language of matter expressing its endless transformations. The colors of the universe remind us that nothing is still. Every wavelength is changing, every tone drifting through time. The cosmos paints itself continuously, each galaxy a brushstroke in an ever-expanding canvas. To see it in full color is to see time made visible, a spectrum not of light alone, but of existence unfolding. In the end, color is more than perception. It is the heartbeat of the cosmos, the translation of energy into beauty, of physics into art. Every shade in the night sky is a memory of something that once burned, lived, and faded, still reaching across space to tell its story in light. The light that leaves a galaxy begins its voyage in purity, blue, white, gold, its color determined by the temperature of the stars it carries. Yet, by the time that same light reaches human eyes, it has changed. Its once tight waves have stretched, its hue softened, its energy weakened. It has drifted toward the red. The further the galaxy, the deeper the red. What appears as color is not illusion but language, and in this deepening red lies one of the universe's greatest revelations that space itself is expanding, carrying galaxies apart and dragging their light into lower frequencies. At first, the redshift was seen as a puzzle. When astronomers studied the spectra of distant galaxies, they noticed that the familiar patterns of chemical lines, the fingerprints of elements, were all displaced toward the red end of the spectrum. Every line of hydrogen, every mark of calcium or oxygen was shifted by the same amount. It was as if the light itself had been stretched, its rhythm slowed. The galaxies were not where their light suggested they should be. They were moving away. The principle was simple yet immense in implication. Light behaves as a wave. When the source of the wave moves away, its wavelength lengthens just as the pitch of a receding siren drops. The same happens with light, though on a cosmic scale. But what astonished scientists was that this shift appeared universal. Every distant galaxy, in every direction, showed the same trend. None approached, all receded. The universe was not static, it was growing. This was not merely a matter of motion through space. The galaxies were not racing away through a pre-existing void. The void itself was expanding. The fabric of space-time, the stage on which all matter exists, was stretching. Every galaxy was like a point on the surface of an inflating sphere, moving away not because it chose to, but because the very space between them was swelling. The redshift was not a product of speed alone. It was the evidence of creation continuing, the universe unfolding before us. The deeper the observation, the stronger the shift. Galaxies near the Milky Way displayed only faint reddening, their wavelengths modestly stretched. But as telescopes reached further, the redshift grew extreme. Light from galaxies billions of light-years away was shifted so far that visible colors vanished entirely, sliding into infrared. These galaxies were not just far, they were ancient. Their light emitted when the cosmos was young. Each measure of redshift became a measure of time itself, the degree of stretching a direct record of the universe's age and rate of expansion. From these measurements emerged one of the most profound understandings in science. The universe has a beginning. If everything is expanding now, then at some earlier moment, everything must have been closer compressed into a state of unimaginable density and heat. The redshift was not only proof of motion, but a clue to origin. It pointed backward, toward a time when the universe was condensed into a single, blazing moment, the birth of space and time. Yet, the redshift carries more than history. It carries destiny. As the expansion accelerates, galaxies move away faster and faster. There will come a time, far in the future, when their light will be stretched beyond reach, fading from visibility. The sky will darken not because stars die, but because their light can no longer cross the swelling distances. Redshift is not only a record of the past, it is a prophecy of solitude. The study of redshift has also become a map of structure. By measuring how much a galaxy's light has shifted, astronomers can calculate its distance and motion, charting the cosmic web in 3 dimensions. What appears as a flat pattern of stars unfolds into depth and shape clusters, filaments, and voids revealed by the language of color. The universe can be seen not as an image, but as a moving symphony of receding light, every note tuned by expansion. On the edge of the observable cosmos, the redshift becomes extreme. The most distant galaxies, revealed by telescopes like the James Webb, appear so red that their light is barely light, at all faint waves stretched into the infrared, ancient signals from the first moments after darkness lifted. To capture them is to witness the dawn of everything. Their glow, dulled by time and distance, is a message from the beginning, crossing the ever-expanding gulf to tell us that creation still echoes. There is something deeply poetic in the idea that distance transforms color. The redness of faraway galaxies is not decay, but evidence of motion proof that the universe is alive, restless, and unfinished. The further we look, the older the light, and the more the universe appears to fade, not because it is dying, but because it is still unfolding beyond sight. Each ray of stretched light is a conversation between what was and what is. It tells us that even in vast separation, connection remains. The galaxies flee, but their light still reaches us, carrying the imprint of their flight. Redshift is the memory of expansion, the scar of creation written in color. And as the cosmos continues to swell, the light will keep stretching, the colors will keep deepening, and the story of motion will go on forever, written in the reddened glow of the stars. In the beginning, the universe was almost perfectly smooth, a vast ocean of hydrogen and helium gas, uniform and unbroken, expanding in every direction. But within that stillness, small imperfections existed, tiny ripples of density, born from quantum fluctuations in the earliest moments, began to pull matter toward them. Over billions of years, these ripples deepened into rivers, and those rivers became the filaments upon which galaxies would one day be strung. Out of that ancient quiet, the universe wove itself into a grand and delicate tapestry, the cosmic web. When astronomers first began to chart the positions of galaxies across space, they expected to find randomness. What they discovered instead was a pattern intricate, interconnected, and alive with structure. Galaxies were not scattered evenly through the void. They gathered along invisible threads, forming colossal chains and walls that stretched for hundreds of millions of light years. Between those filaments lay vast, empty spaces, cosmic deserts so immense that entire clusters of galaxies could fit within their silence. This architecture became visible through deep surveys of the sky. Each point of light mapped in 3 dimensions revealed that the universe was not chaos, but order on the largest possible scale. Galaxies clustered like dew along spider silk, outlining a skeleton of creation. The spaces between them were not absence but balance, the negative of a cosmic photograph. The pattern was everywhere, from the smallest groups of galaxies to the largest structures ever observed. Some of these structures defy imagination. The Sloan Great Wall, a filament stretching over 1 billion light-years, connects galaxies across a span so large that its light began its journey before life on Earth took form. The Hercules Corona Borealis Great Wall is larger still, an almost mythic bridge of matter whose size challenges the limits of cosmic uniformity. These titanic formations are not single objects, but the collective gravity of billions of galaxies, drawn together by the unseen hand of dark matter. Dark matter is the hidden weaver of the cosmic web. Though invisible and undetectable by ordinary light, its presence shapes everything. It exerts gravity, but emits no radiation. It neither glows nor absorbs, yet it sculpts the universe. Simulations of cosmic evolution reveal that dark matter collapsed first, forming invisible scaffolds where ordinary matter gathered. Along these invisible threads, gas condensed, cooled, and ignited into stars. Without dark matter's silent gravity, there would be no structure, no galaxies, no stars, no life. The filaments of the web are like veins of the cosmos, pulsing with galaxies and clusters. Within them, superclusters form massive congregations where thousands of galaxies orbit within a common gravitational domain. Each cluster shines with the light of trillions of suns, yet it is only one strand among countless others. The spaces between these filaments are the void's regions nearly empty, their rarefied gas too thin to kindle stars. In these voids, darkness reigns unbroken. They are the true wilderness of the universe, places where light barely passes and gravity whispers faintly. To visualize the cosmic web is to glimpse creation's geometry. It looks almost biological filaments and nodes, resembling neural networks or the roots of a vast organism. On every scale, the pattern repeats, fractal and self-similar, suggesting that the laws of physics sculpt the universe with a kind of artistry. From microscopic quantum fluctuations to superclusters spanning billions of light years, the same mathematical rhythms echo across scales. But even within this grandeur lies fragility. The galaxies bound within filaments are in constant motion, drawn toward regions of higher density. Over time, gravity tightens its grip, pulling clusters together even as the expansion of space stretches them apart. The web is not fixed, it evolves, stretches, and thins as the universe grows. In distant ages to come, as expansion accelerates, the threads may fray. The cosmic web that now binds the universe in unity will eventually unravel, its filaments stretched into invisibility, its connections lost to distance. For now, though, it stands as one of the most exquisite revelations of cosmic science, that out of randomness emerged order, and out of simplicity, structure. The web is the universe's handwriting, the mark left by gravity on the blank page of space. It is proof that the cosmos is not an empty abyss, but an intricate network of relationships, every galaxy tied to others across the immensity of time. When telescopes capture maps of this grand lattice, what appears on the screen is more than data. It is the face of the universe itself, a portrait of its invisible architecture. Each filament glows faintly with the memory of creation. Each void hums with the echo of what never formed. Together they tell a story that began in silence and continues in motion, a story written not in words or sound, but in the quiet geometry of light and gravity. To drift across the cosmic web is to travel through the veins of existence itself. Every filament, every cluster, every void is a reminder that the universe breathes, stretches, and connects all things, seen and unseen. And in that grand design lies a simple truth. Even across billions of light years, everything is connected by the invisible threads of gravity, woven into a single, infinite whole. In the quiet vastness of the cosmos, motion never ceases. Every galaxy, no matter how serene it may appear, drifts upon invisible tides of gravity. These movements are slow beyond comprehension, millions of years for a single orbit, billions for a meeting, yet in cosmic time, they are inevitable. The great islands of stars do not remain apart forever. They fall toward one another, drawn by mutual attraction, and when they meet, the darkness between them ignites with chaos and creation. Galactic collisions are the universe's grandest symphonies, played out over eons, where destruction and birth become one. To imagine such an encounter, one must abandon all sense of human time. When two galaxies approach, they do not crash like solid worlds. They are mostly emptiness, their stars separated by vast distances, their matter diffused like mist. The meeting unfolds slowly, gracefully, as gravitational tides stretch and twist them into new forms. Spiral arms distort into bridges of stars. Clouds of gas are torn apart, colliding to form shockwaves that awaken dormant material into brilliant storms of star birth. The night becomes a forge where pressure, heat, and gravity craft new suns from chaos. Through telescopes, astronomers have captured these moments frozen in light. Some galaxies are caught mid-collision, their shapes entwined like dancers in a silent waltz. Others bear the scars of ancient mergers, elongated tails of starlight stretching into the void, or luminous rings where waves of gas ripple outward from the impact. These cosmic encounters are not rare exceptions. They are the rule of evolution. Every large galaxy we see, including our own, is a survivor of countless such unions. The Milky Way itself carries the evidence. Streams of stars in its outer halo mark the remnants of smaller galaxies it has absorbed. The Sagittarius dwarf, once independent, now dissolves into our galaxy's gravitational embrace. And far ahead, in the deep future, the Andromeda galaxy approaches. Though its light appears calm and distant, it is moving toward us at immense speed. In roughly 4 billion years, the two great spirals will merge, their stars mingling in an epic collision that will transform both forever. When galaxies merge, their central black holes also converge. Each galaxy's heart, invisible and immensely heavy, begins to spiral inward toward the other, locked in a gravitational dance that can last hundreds of millions of years. As they draw closer, the surrounding gas and dust are stirred into violent motion, feeding the black holes until they blaze as quasars' cores so luminous they outshine entire galaxies. From their collision will emerge gravitational waves, ripples in the fabric of space-time, carrying the memory of that union across the universe. Such collisions are not purely destructive, they are acts of renewal. When clouds of interstellar gas crash together, they compress into regions dense enough to collapse under their own gravity. New generations of stars ignite, lighting the aftermath with radiant blue clusters. From the death of one structure comes the birth of thousands of suns, each with the potential to host planets and perhaps, one day, life. The galaxies are not destroyed, they are reborn, reshaped into new forms. The universe creates through violence. Astronomers have observed this drama in all its stages. The antennae galaxies, locked in mid-collision, spread luminous arms into space, dotted with hundreds of star-forming regions. The Cartwheel galaxy, struck long ago by a smaller companion, glows with concentric rings of newborn stars rippling outward. The Tadpole galaxy trails a stream of scattered stars extending hundreds of thousands of light-years, a record of motion and time written in light. Each image tells the same story. Gravity is the sculptor, and time is its chisel. The true scale of these interactions defies imagination. A galactic collision lasts hundreds of millions of years. For most of that time, individual stars never touch. Instead, their gravitational fields shift, altering orbits, reshaping the galaxy's architecture. What collides most violently is not the stars but the gas, the raw material of new creation. The aftermath is a chaos of light, a brief cosmic firestorm before the system settles into calm once more. When the merging is complete, what remains is a single, larger galaxy, rounder, smoother, older, carrying within it the memory of its ancestors. The universe's beauty lies in this duality, the elegance of destruction serving creation. Galaxies collide not out of choice, but out of inevitability. Their motion through the cosmic web ensures encounters, and through these encounters, structure evolves. Without collision, galaxies would remain small and dim. The grand spirals and brilliant ellipticals we see today exist because of countless ancient mergers. Every luminous world, every sun that rises over an alien horizon, owes its existence to the chaos of these cosmic unions. And when the light of those collisions finally reaches Earth, billions of years after the event, it carries not the violence of the act, but the serenity of completion. The forms we see are frozen, peaceful, glowing in the quiet aftermath of unimaginable power. They remind us that the universe is not still but alive, constantly reshaping, erasing, and rewriting itself. In that continual cycle of destruction and rebirth lies the essence of cosmic evolution. to watch galaxies collide is to glimpse time at its grandest scale, a reminder that even the largest structures are impermanent, that everything, from stars to civilizations to galaxies, is part of an ongoing dance. The darkness between them is not emptiness, but the stage upon which creation performs its endless silent music. There are things in the universe that shine, and there are things that hold the shining together. Between the stars, beyond the reach of any light, lies an invisible presence that shapes everything we see. Galaxies spin, clusters form, cosmic webs stretch, all because of a substance that cannot be touched, tasted, or seen. It neither reflects light nor absorbs it, yet its gravity is undeniable. It is the scaffolding of the cosmos, the silent architect that gives the universe its form. This unseen presence is known as dark matter. The story of dark matter began with confusion. When astronomers measured the speeds of stars orbiting the centers of galaxies, they found something impossible. The outer stars were moving far too fast. By Newton's laws, galaxies should have flown apart, their edges scattered into the void, but they held together. There was only one explanation: something unseen must be providing the extra gravity needed to bind them. That invisible mass, though silent, outweighed everything visible. In the 1930 seconds, the Swiss astronomer Fritz Zwicky studied clusters of galaxies and found the same mystery. The galaxies within those clusters moved as if they were being pulled by an unseen hand. The visible matter, the stars, the gas, the glowing dust, was not enough to explain their motion. He called this missing mass, dunkel materie, dark matter. At the time, few believed him. The idea that most of the universe could be invisible felt absurd. But decade by decade, the evidence grew, until disbelief itself became impossible. When Vera Rubin later measured the rotation curves of spiral galaxies, she found the same pattern Zwicky had hinted at. The stars in the outer arms moved at nearly the same speed as those near the center, defying all expectations. The gravitational pull required to sustain such motion could not be explained by the stars alone. Something unseen was there, an invisible halo of matter, extending far beyond the galaxy's luminous disk. Every spiral, every cluster, every galaxy bore the hidden fingerprint of this ghostly mass. Today, dark matter is known not through sight, but through its effects. It bends the path of light from distant galaxies, creating distorted images known as gravitational lenses. It shapes the distribution of galaxies across the cosmic web, drawing them into filaments and clusters. It forms halos around every galaxy, invisible cocoons that give them weight and stability. Without it, the universe would have remained formless, a cloud of gas too dispersed to create stars. Dark matter is the framework upon which all structure is built, yet no one knows what it is. The nature of dark matter remains one of the greatest unsolved mysteries in physics. It is not made of atoms. It does not interact with electromagnetic radiation. It passes through normal matter as though it were not there. The leading theories propose exotic particles weakly interacting massive particles, axions, sterile neutrinos, each elusive, each theoretical, each unconfirmed. Physicists have built detectors deep underground, shielded from cosmic rays, waiting for a single whisper of dark matter to collide with ordinary atoms. So far, there has been only silence. But the silence speaks of something profound. Dark matter must exist in staggering quantity. For every gram of visible matter, stars, planets, gas, there are roughly 5 grams of dark matter. The universe we can see is only a small fraction of what truly exists. The rest lies hidden, governing motion, sculpting galaxies, and binding the cosmic web together. What we call reality is merely the illuminated surface of a much greater, invisible ocean. To visualize dark matter is to imagine a ghostly structure that envelopes every galaxy. It does not emit light, yet it defines the shape of light's domain. It extends beyond the glowing spiral arms, reaching far into the surrounding void. If we could see it, the night sky would appear as a vast network of luminous fog halos connected by filaments, surrounding each galaxy like a transparent cocoon. The visible stars would appear as bright dust grains floating within colossal, unseen spheres. Dark matter does not simply hold galaxies together, it orchestrates their very formation. In the early universe, when gas was still diffuse and the first atoms were forming, dark matter provided the gravitational seeds that pulled matter inward. Where dark matter gathered densely, galaxies would later ignite. Where it was sparse, voids would remain. Every star that burns today was born within a cradle woven by the pull of something invisible. And yet, for all its influence, dark matter remains beyond human touch. It is as if the universe has chosen to hide its foundations. The light we see, the galaxies we map, the stars we name, all of it is merely the surface pattern of a deeper design. Dark matter is the silent sculptor of that design, invisible but essential, present in every rotation of every star. Perhaps the mystery of dark matter endures because it mirrors the nature of knowledge itself. We are beings made of light, trying to understand the dark. We measure what we can, infer what we cannot, and in between those limits we find meaning. The cosmos does not reveal all of itself, and maybe it never will, but in that hiddenness lies beauty. Dark matter is not absence. It is structure unseen, gravity incarnate, the quiet hand that shaped the galaxies and still guides them. Every rotation, every orbit, every pattern of stars is a trace of its influence. The universe, luminous and vast, rests upon this invisible framework, a sculpture carved from gravity and silence. Before galaxies, before stars, before even the first light, there was only the faint hum of creation. The universe was a sea of energy and simplicity, its particles dancing in chaotic unity, its heat immeasurable. Time and space were still smoothing themselves out, and silence had not yet begun. The cosmos then was not the velvet darkness we know, but a glowing fog of pure radiation. As it expanded, that radiance thinned, cooled, and stretched until it became something faint, something ancient, a whisper. That whisper still fills all of space, everywhere, always. It is the memory of the universe's birth, the cosmic microwave background. The discovery of this whisper came not from the search for origins, but from curiosity about noise. In 1965, two radio engineers, Arno Penzias and Robert Wilson, were testing a new antenna built to communicate with satellites. No matter how they tuned it, a strange, static, persisted faint, uniform, and constant from every direction. They cleaned the instrument, removed interference, even chased away the pigeons that had nested within its giant horn. Yet the noise remained. Only later did they realize what they were hearing. The sound was not from Earth, nor from the galaxy, but from the universe itself. What Penzias and Wilson had stumbled upon was the remnant glow of the Big Bang radiation that had traveled for nearly 14 billion years, cooled and stretched by expansion until it fell into the microwave range of the electromagnetic spectrum. It was the first light that ever escaped darkness, still washing over us like an echo from time's beginning. That faint signal, once noise, became one of the greatest discoveries in science, confirming that the universe was born hot, dense, and expanding. The cosmic microwave background, or CMB, is the oldest light we can see. It comes from a time when the universe was only 380,000 years old, long before the first stars. At that time, matter and radiation were intertwined, forming a plasma so dense that light could not travel freely. The universe was opaque, like the inside of a glowing fog. As it expanded and cooled, protons and electrons combined to form neutral atoms, allowing light to finally move unimpeded. That moment when the universe became transparent is what we see today as the CMB. Every photon from that era has been traveling ever since, unchanged, a direct message from the dawn. To study this ancient light is to read the first chapter of existence. Modern telescopes like COBE, WMAP, and Planck have mapped the CMB in exquisite detail, revealing that it is not perfectly smooth but slightly uneven. These tiny temperature variations, differences of mere millionths of a degree, are the seeds from which all structure in the universe grew. The galaxies, clusters, and cosmic webs we see today began as faint ripples in this early glow. Gravity amplified those ripples over billions of years, pulling matter into denser regions while leaving vast voids between them. The entire architecture of the universe was encoded in those early whispers of light. The CMB also carries the universe's geometry within it. By measuring its patterns, scientists can determine the curvature of space, the density of matter, and the rate of cosmic expansion. The data reveal that space is remarkably flat on large scales, meaning the universe will likely expand forever. The whisper of ancient light not only tells us where we came from, but also where we are going. But the CMB holds mysteries still. Its subtle asymmetries hint that something deeper may have shaped the early cosmos, perhaps primordial gravitational waves, or the shadow of other universes beyond our horizon. Some regions of the CMB are cooler or warmer than expected, leading to speculation about cosmic imprints left by collisions between universes or the effects of unseen forces during inflation. Each pattern, each faint swirl of temperature, could be a clue to realities beyond our reach. When astronomers translate the microwave signal into color, it forms a map unlike anything else, a soft, speckled sphere of blues, reds, and yellows, representing minute fluctuations in temperature. It is not a photograph, but a portrait of the universe's infancy. To look upon it is to look backward through almost all of time, to witness the moment when light first became free. Every point on that map is a fossil of the past, still glowing faintly in the silence between galaxies. The most humbling truth about the CMB is that it surrounds us completely. No matter where one looks in any direction, at any moment those photons are arriving, gently striking every atom, every planet, every living being. They are the background against which all existence unfolds, the ancient hum beneath the music of the stars. Every sunrise, every glimpse of starlight, happens within the afterglow of creation. The whisper of the early universe is not silence but memory. It is the oldest message still being delivered, the evidence that light itself remembers its origin. To listen to it is to understand that the universe is not a place of static existence, but of continuous remembrance. The faint microwave glow is the breath of the cosmos, still echoing through time, a reminder that even in vast silence, the universe speaks. There was a time when light could not travel freely, when the cosmos was wrapped in a veil so dense that vision itself was impossible. In that early epoch, the universe was a glowing fog of plasma, a sea of charged particles colliding endlessly. Photons, the seeds of illumination, could not move far before scattering against electrons. The sky, if one could have seen it then, would have been a blinding haze without direction or shadow. It was an age without transparency, an age before stars, before clarity, when the universe was opaque. This was the cosmic childhood, a time roughly between the birth of matter and the first dawn of starlight. After the Big Bang, the universe expanded and cooled, but it remained so hot that atoms could not yet form. Protons and electrons drifted separately, their electrical charges ensuring that light was constantly deflected. The cosmos was brilliant but blind, its energy trapped within itself. It was like the inside of a star, radiant, restless, yet unseen. As expansion continued, the temperature fell. Roughly 380,000 years after the beginning, a quiet transition occurred. The charged particles combined to form neutral hydrogen atoms. With their formation, the fog began to thin. Light was finally free to travel. That first escape of radiation became the cosmic microwave background, the afterglow of creation. Yet even as the universe cleared, it soon slipped back into darkness. The newly formed hydrogen absorbed the young light, and no new sources had yet appeared to replace it. Thus began what astronomers call the cosmic dark ages. The universe was vast, cold, and nearly featureless. The primordial hydrogen and helium filled space in smooth, invisible sheets. There were no stars to burn, no galaxies to shine, no warmth except the fading memory of the Big Bang. The cosmos, for hundreds of millions of years, existed in a kind of sleep, expanding silently, waiting for gravity to work its slow magic. Within that darkness, small fluctuations in density, tiny irregularities left imprinted in the microwave background, began to gather matter together. Hydrogen drifted into knots under gravity's pull. These knots became clouds, and those clouds grew denser and hotter at their cores. The first sparks of fusion ignited within them. When the first stars lit their fires, the cosmic fog began to lift again. Light returned, not as a uniform glow, but as the flickering of individual beacons scattered through the void. This transformation, known as reionization, marked the end of the opaque universe. The ultraviolet radiation from the first stars and galaxies split hydrogen atoms apart once more, turning neutral gas back into an ionized plasma, but now so thin that light could pass freely through it. The fog did not return. The universe had become transparent, and its great cosmic structures could finally emerge in full view. The first starlight carved tunnels of clarity through the darkness, illuminating vast pockets of space. Around each of those early stars formed expanding bubbles of ionized gas, which grew and merged into an interconnected network of illumination. Within a few 100 million years, the entire cosmos was reionized, the age of opacity ended, replaced by a universe alive with light. Modern telescopes now peer into that long-lost era, searching for the boundary between darkness and dawn. The faint infrared glow from distant galaxies shows us the moment the fog lifted when the universe, for the first time, could see itself. Each observation of these ancient lights is a glance into the last frontier of invisibility, the transition between the hidden and the revealed. The opaque age may seem lifeless, but it was necessary. It was the womb of the cosmos, where the ingredients of everything familiar were quietly arranged. Without that long darkness, the first stars could not have formed, and without those first stars, the elements of life would never have existed. The opacity was not an absence of light, but the preparation for its birth. To imagine that time is to imagine a universe before beauty, before color, before vision, a universe humming softly in the language of potential. The darkness then was not emptiness but waiting. From that waiting came light, structure, and awareness. The fog of the early cosmos was both barrier and promise, and when it finally thinned, the universe opened its eyes for the first time. At the center of almost every galaxy lies something so dense and so powerful that it defies comprehension. It is invisible, yet it dictates the motion of billions of stars. It exerts such force that not even light can escape once it crosses a certain boundary. These cosmic engines are supermassive black holes, the hearts of galaxies, silent and immense, shaping their hosts across cosmic time. A supermassive black hole is unlike any other object in existence. Its mass can range from millions to billions of times that of the Sun, compressed into a region no larger than a solar system. Space around it is warped into a funnel so deep that time itself slows. Within that boundary, the event horizon, gravity becomes absolute. What enters never returns. Yet, paradoxically, it is not darkness that marks these monsters, but light intense, radiant, almost unbearable light, born from matter spiraling into their grasp. As gas and dust fall toward a supermassive black hole, they do not plunge silently. The material forms a swirling accretion disk, compressed and heated to extraordinary temperatures. Friction and magnetism ignite it into brilliance. The disk shines across the spectrum, from X-rays to visible light, outshining entire galaxies. Some of this energy escapes in colossal jets, streams of charged particles flung from the black hole's poles at nearly the speed of light, piercing the galaxy's halo and beyond. These are quasars, the brightest beacons in the universe, powered by the darkest of engines. When astronomers first discovered quasars, their brightness seemed impossible. They were compact, smaller than the solar system, yet radiated more energy than a trillion suns. Only the presence of supermassive black holes could explain such fury. The light we see from these distant quasars began its journey when the universe was young, revealing that even in its earliest epochs, black holes already existed, fully grown, massive, and dominant. How such enormous structures could form so quickly remains one of the great cosmic enigmas. Black holes may begin as the collapse of massive stars, but supermassive ones are another story. They are thought to have grown from the merging of smaller black holes, or from the direct collapse of giant clouds of gas in the early universe. Over billions of years, as galaxies collided and merged, their central black holes also found each other, spiraling inward until they became one. Each union released gravitational waves, ripples in space-time that carry the memory of these cosmic mergers across the universe. The relationship between galaxies and their supermassive hearts is intimate. Observations show that the mass of a galaxy's central black hole is closely tied to the mass of its bulge. The dense, star-filled core of the galaxy. This connection suggests that galaxies and black holes grow together, influencing each other's evolution. As the black hole feeds, it releases energy that can blow gas out of the galaxy, halting star formation. It acts as both creator and destroyer, regulating the growth of its home. In a sense, the black hole is the galaxy's pulse, governing the rhythm of its life. Despite their power, supermassive black holes are not eternal tyrants. When they have consumed all nearby material, they fall silent. Their disks fade, their jets vanish, and they become invisible again, detectable only by the dance of stars around them. The quiet black hole at the center of the Milky Way, known as Sagittarius A*, is one such sleeping giant about 4 million times the mass of the Sun, yet so calm that it would be invisible without sensitive instruments. Occasionally it stirs, flaring briefly as it swallows a passing cloud or star, then returns to rest, waiting for the next offering. The recent imaging of a black hole's shadow, a glowing ring of gas orbiting the abyss, gave humanity its first direct glimpse of one of these monsters. The image was not simply a photograph. It was a confirmation that what theory had long predicted was real. The silhouette against the glowing disk is not an object, but an absence, a perfect curve marking where light itself surrenders. It is both terrifying and beautiful, the purest expression of gravity's authority. To stand beneath a sky filled with galaxies is to know that each of those distant spirals, each of those glowing cores, holds a supermassive heart within it. These invisible engines have shaped the universe on every scale, dictating the flow of matter, the birth of stars, and the structure of the cosmic web itself. Without them, galaxies might never have taken form, and the universe would lack its most dramatic contrasts between light and shadow. In their silence, supermassive black holes embody paradox. They destroy yet illuminate. They consume yet give shape. They are the still centers around which chaos spins, the gravitational anchors that bind creation. The universe, vast and luminous, owes much of its beauty to what cannot be seen to these dark hearts that beat in the core of every galaxy, unseen but essential, forever whispering through the fabric of space and time. Every telescope that peers into the darkness is a device built to look backward. When its mirror gathers light from the heavens, it does not capture the present, it collects the past. The glow of a nearby star may be a few years old. The shimmer of a distant galaxy may be billions. In this way, every observation becomes an act of time travel. Each photon that reaches an instrument began its journey long before there were eyes to see it, carrying the memory of an earlier universe. The deeper astronomers look, the further back they reach. The great telescopes, both on mountaintops and in orbit, are not just tools of sight but of chronology. They open windows into different epochs of cosmic history. When we look at galaxies billions of light years away, we see them as they existed when the universe was young, perhaps only a few 100 million years after the first stars were born. The night sky is a layered archive, each distance corresponding to an earlier page in the universe's story. The Hubble Space Telescope transformed this understanding. Floating above Earth's atmosphere, it captured light, unblurred by air, revealing a cosmos filled with faint, distant galaxies that no ground-based telescope could see. Its famous deep-field image, a small patch of sky that appeared empty to the naked eye, revealed thousands of galaxies. Each speck was an entire system of stars, many formed in the first few billion years of cosmic time. In a single frame, Hubble showed that the universe was far richer and older than imagination had ever dared. As technology advanced, humanity built instruments capable of seeing beyond visible light into the infrared, where ancient photons stretched by the universe's expansion still linger. The James Webb Space Telescope was designed for this very task. With its enormous mirror and exquisite sensitivity, it looks through time to the epoch of first light, detecting galaxies so distant that their glow began when the cosmos was still in its infancy. These galaxies appear small, chaotic, irregular, the universe, still learning how to build order from turbulence. Infrared light is the key to this journey because it carries the oldest signals. As space expands, it stretches the wavelengths of light, turning visible radiation into infrared. What was once blue starlight from young galaxies has become faint warmth drifting through the cosmic dark. The instruments aboard Webb and its successors are tuned to these subtle frequencies, able to sense the dimmest echoes of the earliest suns. They are not just looking farther, they are looking deeper into the past than any eye has before. But the concept of a galactic time machine is not limited to the telescopes themselves. The galaxies are the machines. Each one is a chronicle of time, preserving evidence of the conditions that shaped it. Their colors, shapes, and compositions act as historical records. Young galaxies glow with hot blue light, bursting with newborn stars. Older ones radiate red, their fuel mostly spent. By studying them at different distances, astronomers reconstruct how the universe evolved from turbulent beginnings to the grand spirals and vast ellipticals that dominate today. In the laboratory of the cosmos, light is the data, and space is the archive. Every photon tells a part of the story, and every telescope is an interpreter. Some instruments collect visible light, others capture radio waves or X-rays, each revealing different layers of reality. Radio telescopes trace the cool hydrogen gas between galaxies, mapping the unseen scaffolding of the cosmic web. X-ray observatories expose the fierce glow of black holes and colliding clusters. Together, these tools weave a multidimensional portrait of the universe through time. What makes these observations profound is their inevitability. When we look far enough, we reach a limit, a wall beyond which no telescope can see, because the universe was once opaque. That boundary, marked by the cosmic microwave background, is the horizon of light itself. Beyond it, there is only darkness, the era before transparency. Each improvement in technology pushes that horizon closer to its origin, but it can never cross it. The first moment of light remains forever hidden, its echoes the closest we can come to the beginning. Even so, the act of reaching backward transforms the present. Every photon that arrives tells us not only about the universe's past, but also about its expansion, its fate, and the physical laws that govern everything within it. The data gathered from distant galaxies allow us to measure cosmic acceleration, the distribution of dark matter, and the role of dark energy. In this way, looking into the past becomes a way of predicting the future. There is a quiet poetry in knowing that light never forgets. The photons that left the first galaxies billions of years ago are still traveling, crossing the vast emptiness to bring their story to us. Every telescope that catches them performs a small miracle, turning distance into history, silence into revelation. Through these instruments, the universe teaches that time is not linear but layered, each layer preserved in light. To gaze into the deep sky is to step into that layering, to witness creation frozen in motion. The galaxies we see are not ghosts, but messages, evidence that time can be preserved, that the past still exists, written in photons wandering the dark. Every telescope is a bridge across epochs, and every act of observation is a reunion with what was. In the glow of ancient galaxies, humanity meets its own beginnings. Not every galaxy blazes with the brilliance of a spiral or the radiance of a quasar. Some drift in silence, their stars scattered thinly across vast distances, so faint that even the best telescopes nearly miss them. These are the ghost galaxies, immense, yet dim, fragile structures that defy expectation. They move quietly through the universe like cosmic phantoms, almost invisible against the black, revealing that light is not the only measure of existence. A ghost galaxy can be as large as the Milky Way, yet hold only a tiny fraction of its stars. Their starlight is spread so widely that they appear as pale smudges, barely distinguishable from the background sky. For decades, astronomers overlooked them, assuming that galaxies of such size and faintness could not exist. Only with the advent of ultra-sensitive detectors and long-exposure imaging did these spectral forms begin to appear enormous yet almost empty. These ultra-diffuse galaxies challenge understanding of how matter arranges itself. Some seem to have formed normally, but were later stripped of gas and stars by gravitational encounters, leaving behind skeletal remains. Others appear to have been born faint, never gathering enough material to ignite vigorous star formation. Their low density means their stars drift far apart, orbiting in slow, delicate harmony, like distant lanterns scattered through a mist. The darkness between them is greater than the light they emit. One of the great surprises about these galaxies is their relationship with dark matter. Some seem to be held together almost entirely by it, their meager starlight floating within vast halos of invisible mass. Others, astonishingly, appear to lack dark matter altogether, existing as fragile arrangements that should not survive long. These exceptions suggest that galaxies can form through multiple pathways, some governed by dark matter, others by the chaotic tides of galactic collisions. To study such faint objects requires patience measured in years. Astronomers use techniques that stack exposures over hundreds of hours, collecting every stray photon. Even then, the light barely emerges from the background noise. The faintest galaxies resemble shadows of galaxies past remnants of larger systems torn apart by gravity's pull. Their stars, freed from their original homes, now drift in ghostly swarms, marking the scars of cosmic encounters. In galaxy clusters, these ultra-diffuse realms float like embers in cooling air. They are survivors of violent histories, remnants stripped of gas by the heat and pressure of the cluster's environment. Without the raw material for new stars, they fade slowly over billions of years, glowing only with the residual light of ancient suns. They are fossils of the universe's more turbulent eras, silent witnesses to the growth of structure. Yet, there are others whose origins remain mysterious. Some ultra-diffuse galaxies are found alone, far from clusters, where no tidal forces could have shredded them. Their isolation raises a puzzle. How can such fragile objects form and persist in the emptiness of intergalactic space? Their stability hints at hidden strength, perhaps anchored by an unusually massive dark matter halo. In this way, even the faintest galaxies illuminate the hidden architecture of the cosmos, revealing where gravity's hand is strongest. In a few extraordinary cases, these ghost galaxies display strange beauty. Wisps of starlight curl around their edges, and their shapes blur softly into the void. Some harbor a few bright star clusters, tiny jewels within a fog of darkness. Others contain no clear center at all, only a gentle diffusion, as if they are dissolving even as they are observed. They look less like islands of stars and more like the afterimages of galaxies, the echo of light after substance has faded. To gaze at one of these faint realms is to confront the boundary between existence and absence. They are real, measurable, and immense, yet they barely register in the senses. Their very faintness challenges the human tendency to equate brightness with importance. The universe, it seems, values persistence as much as luminosity. Even in near invisibility, these galaxies endure, carrying the same cosmic materials as their more radiant cousins. Their discovery has also changed the way astronomers think about the universe's inventory. For every bright galaxy that gleams in the night, there may be many ghostly companions, unseen and uncounted. The cosmos is richer and more subtle than its glittering surface suggests. What was once thought empty may, in fact, be filled with hidden structures, woven from faint starlight and held together by gravity's unseen thread. In a way, ghost galaxies mirror the human search for meaning in the vastness. They remind us that significance is not always measured by brightness, that existence can persist even in quiet obscurity. They drift through space as testaments to endurance, delicate, dim, yet enduring for billions of years. In their shadows, we glimpse the humility of creation and the truth that even the faintest light contributes to the story of the universe. Across the great expanse of space, there is light too faint for any telescope to see. It exists everywhere, woven into the background like an invisible mist, the residue of countless stars, galaxies, and cosmic events that have long since faded. This is the universe's hidden glow, the soft afterlight of creation, scattered and diluted by time. It is not the brilliance of stars, nor the afterglow of the Big Bang, but something quieter, something left behind. It is the lost light of the cosmos, a reminder that even in apparent darkness, the universe never truly forgets its own illumination. Astronomers call this faint radiance the cosmic background light, a diffuse blend of all the photons ever released by stars, quasars, and galaxies throughout history. It stretches across the spectrum: visible, infrared, ultraviolet, but it is almost impossible to detect directly. Each photon has traveled for billions of years, bouncing between dust grains, absorbed and re-emitted, stretched by cosmic expansion until it becomes a whisper. The universe glows faintly, even where no stars can be seen. This hidden light is like an ancient archive, containing the memory of everything that ever burned. The challenge lies in reading it. Unlike the clean signal of the cosmic microwave background, this light has no single source, no uniform pattern. It is a collage of countless histories, light born in the first galaxies, dust heated by dying stars, the faint shimmer of intergalactic gas warmed by gravity itself. To detect it is to listen to the static between cosmic notes. When scientists attempt to measure this background glow, they find it brighter than expected. There appears to be more light between galaxies than all known sources can account for. It is as if the universe is illuminated by something unseen, a population of hidden stars, orphaned planets, or faint dwarf galaxies that escaped detection. Some suggest that this extra light may come from stars ripped free during galactic collisions, now wandering alone through intergalactic space. These exiled suns, unbound and solitary, drift through the void, their combined glow forming a faint, ghostly haze. Others propose an even more mysterious origin: dark matter itself. If certain types of dark matter particles decay or collide, they could release tiny flashes of energy, invisible yet cumulative over eons. The universe could be filled with such events, each one insignificant alone, but together producing a soft, eternal shimmer. If true, this hidden radiance would be the signature of matter's invisible, half the shadow revealing itself through light. Beyond the measurable glow, there is also missing light photons that never arrive, because something has devoured them. Interstellar dust, though delicate, is efficient at absorbing and scattering radiation. It turns light into warmth, re-radiating it in the infrared. The great clouds between stars are both mirrors and barriers, reshaping the light that passes through them. In this way, darkness becomes a sculptor too, bending illumination into new forms. At the largest scales, clusters of galaxies themselves cast shadows. Their immense gravity bends light from behind them, focusing it in some directions and stretching it in others. This gravitational lensing acts as both magnifier and thief, brightening certain regions while dimming others, redistributing light like a cosmic tide. The result is that even the geometry of space determines what we see and what remains hidden. There are times when the lost light reveals itself unexpectedly. A dying star's faint echo may appear in the ultraviolet glow of a nebula. A forgotten galaxy, invisible in optical light, emerges in deep infrared maps. Each discovery adds another thread to the tapestry, another reminder that what is unseen still exists, waiting for the right eyes to find it. Yet much of the universe's radiance will remain forever out of reach. The oldest photons have been stretched so far by expansion that they are too weak to register on any detector. Others have been absorbed by dust or scattered beyond recovery. The night sky that appears dark is not empty, it is filled with light, too tired to be seen. The universe glows in invisibility, its energy dispersed but eternal. There is a quiet beauty in that idea, that even what seems lost still endures in some form. Every star that ever lived contributed to this diffuse background, each photon a fragment of memory traveling endlessly. The cosmos is illuminated not only by what burns now, but by what once burned. The darkness we see is not absence but accumulation, a canvas of forgotten light painted over eons. Perhaps this hidden glow mirrors the nature of understanding itself. For every truth we can see clearly, there are countless others faintly glowing beyond our perception, contributing to the fullness of reality, even if they go unmeasured. The universe, like memory, is layered part seen, part lost, yet all connected. To look for the lost light is to acknowledge that even the faintest glow matters. It is to remember that creation leaves traces in every corner of space, that darkness is never complete, and that every photon, however small, however old, is part of the same ancient song, still echoing through eternity. There are moments when the vastness of the universe feels like a mirror. In every distant galaxy, spinning and evolving light years away, there may exist echoes of our own story, not in detail, but in rhythm. The same forces that shape the Milky Way also shape them. Gravity, drawing gas into stars, collisions igniting new worlds, time erasing what was once bright. The repetition is not coincidence, but consequence. The laws of nature are universal, and in obeying them, every galaxy becomes a reflection of all others, each a variation on the same cosmic theme. To look across billions of light years is to witness alternate versions of reality. Some galaxies, young and chaotic, show what ours might have looked like long ago, dense, turbulent, glowing with furious creation. Others, smooth and red, portray what the Milky Way will one day become quiet, settled, its stellar fires dimmed. In this sense, the night sky is a hall of mirrors, each reflection revealing a different moment in time. The light from those galaxies is old, but their stories are ongoing, carried to us through the slow river of photons. Patterns repeat not because the universe is limited, but because it is consistent. Everywhere, hydrogen condenses into stars, stars forge heavier elements, and those elements scatter to form planets. The cycle of birth and decay plays out endlessly, indifferent to scale or location. Yet within that repetition lies individuality. No two galaxies are identical, just as no two snowflakes are alike. Their differences emerge from chance, small variations in density, collisions, and motion that, over billions of years, produce an infinite diversity of forms. Order gives rise to uniqueness. The concept of parallelism extends beyond structure. Within each galaxy, countless stars may harbor planets, and among those planets, conditions may sometimes resemble our own. There could be worlds with oceans, clouds, and winds beneath alien suns, where chemistry dances on the edge of consciousness. If life arises wherever the ingredients and energy align, then perhaps there are minds far away, looking back into the same darkness, wondering if they, too, are alone. Their telescopes, if they exist, would see our Milky Way as one more faint spiral among billions, no more or less remarkable than any other. This idea does not diminish human significance, it enriches it. To be part of a universe capable of producing reflections of itself, worlds, contemplating worlds, is an extraordinary thing. The universe may not think, but through beings capable of reflection, it becomes self-aware. In that sense, every consciousness is a mirror through which the cosmos can observe its own evolution. Each thought, each question about the stars, is a continuation of the universe's attempt to know itself. Parallel reflections also exist in time. The galaxies we see are not only far away, they are young. Their light began its journey billions of years ago. By the time it reaches us, the galaxies themselves may have changed beyond recognition, merged, faded, or transformed. What we see is a memory, not a current image. The cosmos presents us with its own history, reflected through light. Every observation is a conversation with the past, and every photon is a record of what once was. In this way, the universe teaches that reflection is not static but dynamic. What we see in others, in galaxies, in stars, even in ourselves, is always changing. The act of observation alters understanding, and understanding, in turn, reshapes perception. The mirror is never still. The more we learn about distant galaxies, the more we learn about our own. Their evolution informs ours, and our existence gives their light meaning. Some philosophers of science suggest that the universe may contain more than reflections, that there could be entire parallel realities, separated not by distance, but by dimension. In those hypothetical multiverses, physics might take on different forms, giving rise to alternate versions of existence. Some might be barren, others teeming with different kinds of life, each obeying its own rules. Though these ideas remain speculative, they extend the metaphor. Every possibility may exist somewhere. Every variation may find expression. The cosmos could be an infinite ensemble of mirrors, each universe reflecting a different face of the same underlying truth. But even without invoking other realities, the one we inhabit is reflection enough. The galaxies scattered through space are reminders of continuity, of how matter, energy, and time weave the same patterns again and again. Each reflection enriches the others. When we gaze into the depths, we are not looking into strangeness, but into kinship. Every star's light carries the same physics that burns in our sun, the same chemistry that fills our blood, the same origins in the first atoms of the cosmos. The beauty of these reflections lies in their balance between sameness and difference. They remind us that we are not isolated anomalies, but part of a universal rhythm, endlessly repeated, yet never duplicated. The galaxies mirror our beginnings and our destinies, and through them, we glimpse the timelessness of creation, a universe reflecting itself across light, space, and thought. To drift among these reflections in imagination is to understand that the cosmos is both singular and infinite. Every photon is a mirror, every galaxy a reflection, every being a fragment of awareness turning back toward the light. Through those countless reflections, the universe recognizes itself vast, varied, and eternal. Somewhere within the vast machinery of galaxies, a new kind of light appeared not from fusion or flame, but from awareness. It arose quietly on small worlds, orbiting ordinary stars, built from the same elements forged in ancient supernovas. Hydrogen and carbon, once drifting aimlessly through interstellar space, combined to form living systems capable of thought. From these fragile arrangements of matter came curiosity, and from curiosity came reflection. Through consciousness, the universe began to contemplate its own existence. The atoms in a human body were born in stars that lived and died billions of years ago. Iron in blood, calcium in bones, carbon in cells, all of it came from the explosions that seeded galaxies with heavy elements. When life emerged on Earth, the universe turned part of itself into something that could look back. Every thought, every question about the night sky is an echo of the cosmos remembering itself. The observer and the observed are one and the same matter, become mind, stardust given voice. This transformation may be rare, or it may be inevitable. If the laws of physics are consistent throughout the cosmos, then wherever conditions allow complexity, life may eventually arise. Somewhere in the spiral arms of distant galaxies, other minds might have awakened, wondering at the same mysteries. Whether or not such beings exist, the potential itself is profound. The universe has built into it the ability to become aware. Consciousness is not apart from the cosmos, but an extension of its unfolding. When a person gazes at the stars, they are not looking into something foreign, they are looking into their own origins. The brain interpreting the starlight is made of the same particles emitting it. The eyes receiving photons from a distant galaxy are composed of atoms forged in similar furnaces. Observation becomes communion, the universe perceiving itself through different configurations of matter. The barrier between subject and object dissolves. All awareness is cosmic in essence. The realization that the universe can think not as a single being, but as a network of sentient fragments, reframes what it means to exist. Intelligence, creativity, emotion, all emerge from the same laws that govern gravity and light. A neuron fires for the same reason a star shines. Energy seeks expression. Consciousness, then, may be the universe's most complex form of energy flow, the point at which physics turns inward to wonder at itself. This idea carries both humility and awe. Humanity is not central, yet it is essential as one instance of awareness among countless possibilities. The scale of the universe diminishes ego but elevates purpose. To think is to participate in the ongoing act of creation, not by shaping matter, but by understanding it. Every discovery, every equation, every work of art is another way the cosmos becomes self-aware. The light of the mind is as real as the light of stars. Some philosophers and scientists have suggested that consciousness might be a fundamental property of the universe, present in all things to varying degrees from the vibration of particles to the awareness of beings. In this view, the cosmos has always contained the seeds of thought, waiting for structure complex enough to realize it. Whether or not this is true, the emergence of intelligence transforms the universe from a stage of events into a participant in its own story. The act of understanding is itself a form of cosmic evolution. Just as galaxies grow through mergers and stars through fusion, knowledge expands through awareness. Each new insight, each connection drawn between patterns, is a continuation of the same creative process that shaped the first atoms. Science, philosophy, and art become extensions of cosmic activity, the universe exploring not only what it is, but what it means. Even silence participates in this reflection. When one stands beneath the stars and feels small, that feeling itself is significant. It means that the cosmos has produced beings capable of reverence. Wonder is the emotional recognition of connection, the moment when the immensity outside aligns with the depth within. Through awe, the universe experiences beauty. Through empathy, it experiences meaning. In the distant future, when galaxies drift beyond one another's reach and the stars begin to fade, consciousness may still persist in new forms, machines of thought, networks of energy, minds spread across dimensions of space unknown. And if awareness continues, then so does the universe's capacity to reflect. The cosmos will not end in silence, but in memory, a record of its own becoming preserved through those who once thought and dreamed within it. The idea that the universe thinks of itself is both poetic and literal. Every calculation, every song, every question about existence is a continuation of that process. To be alive is to be a fragment of infinity, learning what it is made of. When one contemplates the stars, one completes a loop begun billions of years ago, when matter first became capable of knowing. The universe looks inward through eyes and minds and whispers its own name. In that recognition lies the ultimate symmetry. The observer and the observed are one. The galaxies that drift apart, the atoms that build life, the minds that wonder all, are facets of the same cosmic whole, infinite in form, united in origin. The universe thinks not with words but with patterns, not with intention but with awareness, and in every conscious being, in every moment of understanding, it continues to think still. There is a frontier in the universe that no traveller can cross, and no telescope can pierce a boundary, not of substance, but of time. Beyond it, light has not yet arrived. It is the horizon of the observable universe, the ultimate limit of vision. Everything we know, everything ever seen or measured, lies within this expanding bubble of perception. Beyond it stretches an unseen continuation of reality, silent, unreachable, and infinite. The edge of the observable universe is not a wall, but a measure of distance defined by time itself. Because light travels at a finite speed, we can only see as far as light has had time to travel since the beginning. That distance, inflated by cosmic expansion, is roughly 46 billion light-years in every direction, a sphere centered not on Earth but on every observer. Each point in the cosmos holds its own horizon, each consciousness surrounded by its personal limit of knowledge. The universe extends far beyond, but its farthest regions will remain forever hidden. This boundary is both profound and humbling. It reminds us that what we call the universe is merely the part we can observe, not the totality that exists. Beyond the horizon, galaxies continue to form and evolve, their light stretching toward us but never reaching, trapped by the relentless expansion of space. The farther the universe expands, the more of itself slips beyond view. What we see today is only a fraction of what is a small, glowing center surrounded by infinite darkness. To understand the edge, one must understand how space behaves. The universe is not expanding into something, space itself is stretching. As it does, distant galaxies recede from us faster than light, not because they move through space at that speed, but because space between us grows too quickly for their light to close the gap. The horizon is the distance where expansion outpaces illumination. Beyond that, the galaxies exist, but their messages are forever lost. In this way, the cosmos creates a kind of cosmic solitude. With each passing billion years, more galaxies drift beyond reach. Their light fades, their signals dim, until they vanish from all possible observation. The future will grow emptier not because creation ends, but because the visible universe will shrink from our perspective. A time will come when only the closest galaxies, perhaps only our local cluster, remain visible, suspended in a vast, dark sea. The universe will continue, but our window into it will close. Even now, the light that defines the edge of observability is ancient beyond comprehension. The faintest galaxies, seen by the most powerful telescopes, shine from a time when the first stars were newly born. Their photons began traveling when space was a fraction of its current size. To capture them is to touch the universe as it was near its beginning. Every step deeper into the sky is a step further into the past, until eventually we reach the limit where transparency began, the afterglow of the cosmic microwave background, beyond which no light from earlier times can escape. Some theorists imagine what lies past that boundary. Perhaps the universe beyond our view is much the same, filled with more galaxies, more webs of matter, more light, or perhaps it differs shaped by regions of space that evolved under slightly different conditions. There may even be entirely disconnected realms where the laws of physics vary, where space curves differently, where time itself flows at another rhythm. These possibilities remain unprovable, for the horizon is absolute. The unseen will remain unseen, no matter how far technology advances. Yet this limit is not confinement but wonder. The existence of an edge to our perception ensures that there is always mystery, always something beyond knowing. The horizon defines the boundary between knowledge and imagination, between evidence and faith in the continuity of reality. To look at the edge of the observable universe is to stare into possibility itself, into the unknown that forever beckons. In the faintest red-shifted light, we glimpse the threshold of comprehension. Beyond it, the map of the universe fades into silence. But the silence is not empty. It is filled with everything that is yet unseen, everything that continues to exist beyond reach. Just as the ocean horizon hides the rest of the sea, the cosmic horizon conceals the greater part of existence. The universe does not end where we stop seeing, it simply withdraws into mystery. To stand at that conceptual edge is to feel both small and infinite. Small, because our view is bounded by light's long journey. Infinite, because we are part of a reality that extends without end. The horizon is not a barrier, but a mirror showing the limit of human comprehension and beyond it, the limitless itself. The cosmos expands, and with it expands the reach of curiosity. Even as galaxies slip away, their light remains as testimony. Every photon crossing that final threshold adds to our understanding, marking the frontier of what can be known. The edge of the observable universe is not a line between existence and non-existence, but between light and waiting. Beyond it, the cosmos continues silent, unseeable, yet real, unfolding in its own timeless rhythm. The universe is not still. Every second, space itself grows. The galaxies, carried on invisible currents, drift farther apart, their light stretching into deeper red as expansion quickens. It is a quiet motion, imperceptible on human timescales, yet it defines the destiny of everything that exists. The same force that began with the first burst of creation continues even now, an unstoppable acceleration that will shape the future of all light, matter, and memory. This is the age of eternal expansion. In the early universe, gravity tried to slow the spread of space. The great web of matter tugged inward, its pull opposing the outward rush. For billions of years, this cosmic tension balanced expansion's speed, but as the universe grew, something unexpected began to dominate, a mysterious pressure woven into the fabric of space itself. This phenomenon, called dark energy, does not behave like matter or radiation. Instead of clumping, it pushes. Instead of weakening, it persists. It is not energy moving through space, it is energy of space. And as it became stronger relative to matter, expansion began to accelerate. This acceleration means that the universe will not collapse in a future big crunch. Instead, it will continue to grow forever, carrying galaxies away from one another until the bonds of visibility break. The farther a galaxy lies, the faster it recedes, until its light can no longer outrun the stretching of space. Beyond a certain distance, the expansion is faster than any signal can travel. Those galaxies do not disappear in an instant. They fade slowly, their photons stretched into wavelengths too long for any detector to sense. They slip into invisibility, not through destruction, but through silence. The consequences of this eternal expansion are profound. Over tens of billions of years, galaxies outside our local cluster will vanish beyond reach. The great cosmic web will unravel strand by strand until only our small group of galaxies remains gravitationally bound. The Milky Way and Andromeda, long since merged into a single massive system, will drift alone through a darkening void. The universe will still exist, but the evidence of its vastness will be gone. Future observers, if any remain, will see only the stars of their own galaxy, suspended in endless night, unaware that there were ever others. As time moves forward, the sky itself will change. The stars will burn their last fuel, and new stars will be born more slowly as gas becomes scarce. The cosmic glow will dim, shifting toward red and then toward darkness. The once active galaxies will fade into quiet remnants, cold spheres of ancient stars orbiting in isolation. Even then, expansion will continue, pulling space thinner, stretching light longer, erasing warmth from the void. But the story does not end there. Even as visible light disappears, the universe remains alive with invisible motion. Matter decays into lighter particles. Black holes slowly evaporate through the emission of faint radiation. Over incomprehensible timescales, the last traces of structure dissolve. The cosmos becomes a sparse sea of photons and elementary particles, endlessly expanding, endlessly cooling. The night will no longer be black, but transparent, a space so vast and thin that distance loses meaning. The idea of eternal expansion invites both awe and melancholy. It means that everything beautiful, galaxies, stars, planets, even atoms, is temporary. Entropy will have the final word, spreading energy evenly until no difference remains. Yet within this fate lies a strange elegance. The universe does not end in destruction, but in stillness. It returns to the simplicity from which it began, a calm equilibrium reached not through collapse, but through diffusion. The same laws that gave rise to life, light, and motion also lead inevitably to quiet. Some speculate that this expansion may not be truly eternal, that dark energy might change over time, or that new physics could alter the future. Perhaps the cosmos will one day contract, or spawn new universes from its expanding fabric. But as far as observation allows, acceleration continues unchecked, and the space between galaxies grows ever wider. Eternity, it seems, is not static but expanding. And yet, even in this grand fading, meaning persists. For as long as consciousness exists, the act of understanding gives purpose to motion. To know that the universe is expanding is to participate in that expansion, to transform distance into comprehension. Every equation describing cosmic growth, every observation of a receding galaxy, is part of the same unfolding story. The universe expands physically, and through awareness, it expands inwardly too. In the far future, when light has stretched beyond perception and the last embers of matter drift apart, perhaps new forms of order will emerge, structures born not of gravity, but of thought. If intelligence survives in some form, it may adapt to the thinning cosmos, finding ways to persist in the ebbing energy. In that endurance, the universe will continue to know itself, even as it approaches silence. Eternal expansion is not a tragedy, but a transformation. The cosmos does not die. It evolves towards simplicity. The light that now travels between galaxies will never stop. It will only fade into wavelengths too long to perceive, its energy stretched across infinity. The same expansion that scatters stars also preserves them, spreading their essence into the eternal. In this way, the universe ensures that nothing truly vanishes. Everything becomes part of the endless continuum of space and time. To gaze upon the night sky is to witness this process in motion. Each point of light is moving away, yet its glow reaches us still. We are surrounded by evidence of change, living within the moment between creation and stillness. The universe expands, and so does awareness. And in that expansion of matter, of time, of understanding, the story of eternity quietly unfolds. One day, long after every star has burned its last fuel, and every galaxy has drifted beyond sight, the universe will still glow faintly, not with brilliance or warmth, but with the last whispers of light photons stretched thin by endless expansion, carrying the memory of what once was. This is the final light, the soft afterglow of everything that ever existed, spreading forever through the dark. It will not be the light of stars, for the stars will be gone. Their fuel will have been spent, their cores cooled into black dwarfs, their remnants orbiting in silence. The galaxies that once burned like jeweled storms across the heavens will have dissolved, their forms erased by time. The universe will have entered its quietest age, an era of solitude where even light itself struggles to survive. In that far future, distances will have grown meaningless. Space will have stretched so much that even neighboring remnants of galaxies will be separated by incomprehensible gulfs. The few remaining photons will drift endlessly, their wavelengths stretched beyond measure. Their energy will be faint, their frequency so low that they blend into the very hum of existence. This light will no longer illuminate, but it will persist, an unbroken record of everything that ever shone. Somewhere amid this fading, black holes will continue their slow work. For trillions of years, they will consume the last matter, their gravity pulling in stray particles and radiation. Yet even they will not last forever. Over unimaginable spans of time, they will evaporate, releasing their own final bursts of light, a quiet farewell from the greatest engines the cosmos ever built. Each flash will be brief, yet each will carry the story of countless stars that once fed their hunger. After the black holes fade, the universe will enter an era of almost complete stillness. No light, no heat, no motion strong enough to disturb the calm. Only an ocean of faint particles drifting through the infinite. It will be a universe that has reached equilibrium, not dead, but resting, its energy spread so evenly that nothing new can form. The cosmic clock will still tick, but there will be no one left to count the seconds. Yet even in that silence, there is a kind of beauty. For the photons that survive the remnants of the earliest stars, the last explosions, the echoes of vanished galaxies will continue their journey. They will travel endlessly through the empty vastness, never colliding, never fading completely. In their persistence lies the proof that light, once born, cannot be undone. It can stretch, weaken, and grow cold, but it remains. The final light is eternal motion, the universe's last breath carried across infinity. This distant destiny, often called the heat death, is not an ending in the way life understands endings. It is the fulfillment of the universe's long trajectory toward balance. Every burst of creation, every fusion within a star, every collision of galaxies has contributed to this quiet state. Entropy is not destruction but completion, the point at which everything that could happen has happened. The universe, in its stillness, will finally contain nothing left undone, and yet, the story of the final light may not be absolute. Some thinkers imagine that even this silence might not last, that new universes could bloom from the fabric of this one, tiny fluctuations igniting new bursts of creation. The final light of one cosmos could become the first spark of another. In that view, eternity is not an endless fade, but a cycle, each ending a seed for new beginnings. Whether or not this occurs, the notion carries comfort, that even in stillness, possibility remains. For now, the final light exists only in imagination, billions upon billions of years away. But the photons that will one day drift through that distant future are already being born. Each sunrise, each starlit night, contributes to the radiance that will someday fill the farthest corners of time. Every beam that leaves a galaxy today is part of that final chorus, the universe's long, gentle farewell to itself. When that last light finally fades beyond perception, it will not be darkness that remains, but memory, the record of existence written across the fabric of space. Every particle, every wave, every heartbeat of creation will have left its trace. The universe will not vanish, it will dissolve into remembrance. The silence that follows will not be absence, but peace. The final light is not tragedy but completion. It is the moment when all creation, from the smallest atom to the grandest galaxy, has fulfilled its purpose. The cosmos will exhale, leaving behind a legacy of light that travels on forever. And somewhere, in that endless drift of photons, lies the echo of awareness, the memory of when the universe looked at itself and saw beauty in the dark. End of series. The most incredible facts about distant galaxies drift into deep space.